want the integration, we are now increasing the powers of x. They can use the word integrate the following equation. They can use this symbol to mean integration. They can say find the integral of the following. Okay, this is the same. You're simply talking about increase in the power or in the values of x with respect to a certain function. So y is equal to x to the power 2. When we say integrate, we are simply saying this symbol and then we increase the power of x. It was 2, just add 1 and drop this plus this. Then you say plus a constant. Okay, meaning x to the power of 3 over 3 plus a constant. That's the answer. Okay. Another one. You can say if y is equal to x to the power of maybe 1 over 2, x raised to the power and half, you say I want to increase the values of x, and so if I want the integral of y, I'll say the integral will be such that x with its power of half, I'll just add 1 and drop the same result. You've seen here is 1.5, meaning 3 over 2. I'll drop the same 3 over 2. And then I'll add a constant. That's all. That's the result. Others can say it's the same as saying x to the power 3 over 2. And then it's more like saying 1 over 3 over 2. This will get the inverse. It will mean 2 over 3 plus a constant. Okay. So for integration, we are increasing the powers of x with respect to x for every function of y. We can have y equal to 10 x to the power 2, and then they say find the integration. So we are integrating the value of y with respect to x. So say the integral will be such that turn x to the power of 2, the power will increase by 1, and then over the same 2 plus 1 over 3. That's when we'll add a constant. So from there, it's just a matter of showing that you were increasing the powers of x. Minus 3 plus that. That becomes the integral of 10x to the power 2. Okay. For the other one, we can say, suppose they give you a function y equal to x to the power of 3 plus x to the power of 2 plus x. And then they say find the integration of y with respect to x. We'll say the integral will be such that we'll start increasing these powers. X, you say 3 plus 1, it will be 4. Drop the same 4. Plus x to the power 2, you say x to the power 2 plus 1, it will be 3. Drop the same 3. This is x to the power 1, so you say x to the power 1 plus 1, it will be 2. Drop the same 2 and then include a constant. That will be the answer. So it's more like you are increasing and then dropping the same increase. That becomes integration. Differentiation is the opposite. Drop the power and then reduce the initial power by 1. Okay. So we can say, when y is equal to x, find the integration. So already there is power of 1. So you say the integral will be such that x will be 1 plus 1 is 2 over the same 2, and then you add a constant. Okay, that's the answer. What's the other one? Whatever equation they give you, you only x plus 1. Find the integral of this. We'll simply say the integral will be such that x has a power of 1. And then we'll treat this as any number raised to the power of 0. So that we can have this is equal to that, this is equal to that. And then we say, I can see an x here, I can see an x there. And so the integral will be such that x to the power of 1. 1 plus 1, it will be 2. Divide by 2. X to the power of 0. 0 plus 1, it will still be x of 1 over 1 plus a constant. It's the same as saying x to the power 2 over 2. You are adding to x. You are adding to a constant. That's the answer. That's your answer. So in short, the opposite of differentiation is integration. The opposite of integration is differentiation. So integration will be adding the powers. Even if you have a power of x to the power of, you can say 10, and then we say find the integration. We'll say the integral will be such that we will increase the values of x. So x has a 10 plus 1 to be 11. The moment you add the power, you even drop it as a denominator and add a constant there. That will be your answer. So the integral will be equal to 11 power, x to the power 11 over 11 plus a constant. Okay. What else? Another example. Suppose you have brackets. X plus 1 raised to the power of 2. Okay. So for this one, we'll say there is, if you want, you can multiply. You can say, okay, the value of y is such that you have this x plus 1, another x plus 1. You've seen. It's more like saying this should come twice. And then x times y is the same as saying x times x. X plus x, 2x. 1 times 1 is 1. Once you get there, that's when you integrate and say, let me integrate. You say the integral will be such that x plus 1 will be 3. I mean, x, that is 2 plus 1, 3. Drop the same 3. 2 has a power there of 1. 2x, 1 plus 1, 2. So it will be 2x of 2 over 2 plus this one is the same as saying x to the power of 0. So 0 plus 1, it will be x. 0 plus 1, it will be 1, meaning giving it a value of x. And then we'll say plus a constant. Okay? So that becomes the answer. The other one, it's more like integration and differentiation. These are just too simple. And then we'll look at the application in another video. Any equation they can give you, maybe 1 over 3 x to the power of 2. We're just concentrating on where there is x here. You know, maybe you can have a 10 there. So we'll say this very 10 has got a certain 10 to the power of that. Okay? Meaning there is 1 here. There is just 10 times 1, 10. 1 over 3 x to the power 2. So when we get to the integral, we'll say 1 over 3 will come the way it is. 2 plus 1 is 3. And then we'll drop the same 3. Okay? We'll drop it. and then we'll say 10 to the power, this is 0, plus 1, it will be 10 of x, plus a constant. So down here there will be a denominator of 3, denominator of 3, meaning they are multiplying. You have your x to the power of 3, 3 times 3, 9. 10 of x plus a constant. Okay? Like that. So the next video will start now the application of this. Why is calculus so important in physics, in mathematics? Why is it helpful in any way? So calculus is very helpful when it comes to calculation of the area, the volume, the maximum and minimum values, finding the gradient at any given point. We'll be using the same. Finding you want to find the rates of change. It's very, very important. And so, until the next video, have a nice day.